So here we go. Okay, so very specific directions. I want you to draw a circle, but wait, hold on. So like if this is your paper, your circle needs to be fairly good size, but start by marking the center, and I want a circle like this and a radius to the right side. Okay? Okay, and I want your paper in portrait mode. I think it's going to work better for you. So, okay. Does it matter exactly what?
Never mind.
It doesn't matter what your radius is. No, not at all. Just guess. Just take a stab in the dark. Even though the easiest way to do that would be to connect the corners, but we don't need to do that. Fairly good size. I don't care what the radius is. Just fairly good size. Because that's one of the powerful parts of what we're going to do today is it does not matter what your radius is. What about Mr. Rexroth's bald head? Can you believe how disrespectful she is? I mean, my... Oh, I didn't grab licorice for myself.
Oh no. Perfect circle. Oh my God. That was a hole in the middle of my paper. I did that all by myself. I did that 3 hands.
Oh, I bought 2 packs and I only needed to buy 1? Oh, man. No, you won't. No, you won't. But I will tell you this, just because I'm a nice guy, if you need any help disposing of your licorice at the end of the day because you don't like licorice, let me know. I'll be glad to help. Okay. So here we go. Ready? So this is actually 4.2. I'm going to write this up top. Radians. Okay. Okay. So here's what we're going to do. We're going to carefully take this pull and peel licorice, and we're going to pull it and peel it. We're going to need a few strands. You don't have to get it all the way down to all strands, but I think on the most part, 3 strands will be sufficient.
Oh, I ripped it. Dang it.
I'd do good at surgery except for the passing out when I see blood stuff.
Well, you don't have blood, so you probably would.
No, I'm just joking. Okay. So here's what I want you to do. I want you to take whatever you can, and I want you to line this up so you know that that's the length of a radius. And I just want you to cut that off. And then what I'm going to do is I'm going to start at this spot, and I'm going to wrap my licorice starting at that spot and go around counterclockwise. Okay? So if you want to cut yourself a bunch of licorice first that are in the same length as your radius, then you can. And you guys already know how many pieces you'll need, would be my guess. Now we're going to go all the way around. Oh, this piece is too small. Nom, 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 nom.
So, we do cut them now?
Yeah, well, you cut them the length of your radius.
This is way too small. So then when we can eat them though when it becomes too little?
Oh, yeah. Yep. You have no use for the pieces that are too small. I know. I noticed that too on mine. I'm going to eat a little lead. Eat some lead, man. Well, this is actually not lead anymore.
Do you think you're lying because you want more licorice, bro? You're probably lying.
That wouldn't surprise me. Yeah. Sounds like he
Stealing stuff.
Oh, by the way, while I'm doing this, I want to share a little fact with you. Every once in a while, just as, kind of professional curiosity, I go to the Nebraska Education Jobs website. And I want to let you know that if you are interested in being a math teacher, the demand for that is crazy high right now. There has been, in the state of Nebraska, just in the last 2 weeks, 8 jobs posted that where people need high school math teachers. There's been 8 jobs posted. And this early, usually the hiring isn't really done till March and April. But people know that since it's such a hard thing to fill, they're trying to fill it earlier and earlier and earlier. And there were some jobs that had hiring bonuses. So if you're interested in that or science or whatever, you will have a job, unless AI takes over.
So what do we just leave the gap?
Well, the gap, I don't really care what you do with the gap. Thank you, Caleb. Caleb. I don't use the word kiddo.
Oh, you hate that.
I do not use the word kiddo.
I don't think you I just got some. I don't know, okay? What the heck?
Okay.
Probably stop complaining and say thank you for the liquor.
So, I always wonder what, if administration saw me coming back with a Dollar General bag, if they're like, that's nice. During his planning hour, he's going to go get candy. That's good. Well, it's actually for a good cause. Okay. So, do you have it wrapped yet? Okay, I'll give you guys some more time.
I'm going to leave my gap.
You didn't start at the right spot, though.
Oh.
You didn't start where I told you to start.
Oh, we had to start from
Yeah.
Oh, okay. That's easy fix. Flip your paper around.
No, he started just in the middle of nowhere.
A little bit of
See this radius I have pointing to the right side? To the right side?
that has to point right?
Yeah.
Oh, sorry.
Yep.
Hunter, I get retried, dude. I know, it's like that. Oh my gosh, thick.
This really is not very good licorice.
What? This is the best licorice.
Mm-mm. It just has too much chemical taste to it. Try and be done in another couple minutes. My recording time in the studio gets expensive.
Oh my gosh. Stop. Yes. You can down the street.
Say my name.
I think I might just take back that other thing of licorice and get my money back.
You can do that with food.
I don't know. But if I ever take candy back for money, call my wife because I'm having a stroke of some sort. Okay? Okay, so here we go. First of all, you guys know, why do we start here? Yeah, it's 0, because that is actually, this is what's called standard position. This is 0, And as we go counterclockwise, that's positive. You guys know that. Okay? So this direction is positive, and this direction is going to be negative. Okay? But here's what I want you to label. Right here. Okay? And this. And this. And this. And this. And this. Okay? Yeah, this licorice is not sitting well with me for whatever reason. It helps if you lick it and then it'll stick to the page. Okay. Oh, no. So now here's what I want you to do. I want you to draw this radius as well. Yeah. We've got the important things. I'm going to keep one just so I can stress this right here. Oh, and this one shrunk up a little bit. That's weird. I'm just going to keep one just to show that. Oh, crap. No. I don't care if an administrator walks in because this is a great activity. If they walk in, they can learn something. Okay. So, here's my question. What is this right here?
What is it?
This angle right here, what is that? That's a radian.
I knew it. I was going to say it, but I don't know.
That is 1 radian. Okay? Okay? Let's label all 3 sides of this sector. This wedge here is called a sector. If this is radius, the other side is a radius. Now I'm just labeling length. How long is this over here? It's my arc length, but how long is it? It's radius. It's the same. No, it's exactly the same. That's how we got that length. We cut licorice that was the length of a radius, and we wrapped it around the corner. So those 3 things are equal. Okay? So now we can go ahead and define what a radian is, and which I will ask you on a test. Just like I asked, what is E? A radian is the central angle formed when the arc length is what? Equals the radius.
Is that formed?
Yes. Formed, yes. Thank you. Okay? That's what it is. That's just what it is. Because we could define a degree too. 1 degree is 1/360th of a rotation. That's what a degree is. That's its definition. Okay? A radian, its definition is the first thing you've got to realize, it's an angle. It's an angle measurement that if I take a sector and I adjust it just right so that my arc length is the same as my radius, that is a radian. Okay? Because it intercepts on my circle a radius. Okay? So I asked this the other day, and we already talked about it, but It's about 57.3 degrees. Okay? But I want to talk about how do you know it's about 57.3 degrees? Well, there's a couple different ways you could do it. First of all, this looks an awful lot like an equilateral triangle, doesn't it? Equilateral triangle, 60, 60, 60. But say if I take this other side and I pull it out just a little bit, is that going to make my angle smaller or bigger than 60? If I pull this out.
It'll make it smaller.
It'll make it a little bit smaller. As I pull this out, my angle gets a little bit smaller. So that's one of the reasons why logically it should be a little bit less than 60. But as we looked around, as you had your pieces of licorice on here, you had 1, 2, 3, 4, 5, 6. And if you notice, if I back this up a little bit, which we've already talked about this, about how many pieces of licorice did it take to go halfway around? A little bit over 3, right? If I just go halfway around, it'd be a little bit over 3. Gee, what's a popular number with circles that's a little bit over 3? Pi. So pi radians is 180 degrees. Honestly, radian is what some people call a naked unit. It doesn't need a label. Okay? Because it's just a ratio. It's a ratio of an arc length to a radius. So your units cancel out. It's just 1 or 2 or 3. It's you can say radians, but it really doesn't need a label of any particular sort. Okay? So now from this, we can go ahead and just put on a lot of different things. If this is pi radians, over here is 2 pi, which of course is 360 degrees. Okay? And this gives us a visual of what 1 radian is, what 2 radians is, what 3 radians is, as far as angles goes. Okay? So if I take a look at 3 radians, that's a pretty big angle. 4 radians, that's actually the angle that goes from there. And 5 radians and 6 radians. So a 6 radian angle, I wish I had my licorice. I need, not licorice, but spaghetti. This right there is a 6 radian angle. Okay? So then we can label all the other things that you guys know. Okay? If I go straight up at 90 degrees, what is that? Yeah. It's halfway. If I go down to 270 degrees, what is that? Pi and a half. It's pi and a half, or 3 pi over 2. Okay? So you guys, like I said, you've already been taught this one way, and the end result is exactly the same. Okay? I'm going to change colors just because I can. If you have a need for colors and you want to borrow some from me, you always can. Let's cut these in half. What if I go to 45 degrees? Quarter. Or, think about it this way, 45 goes into 180 4 times, so it's 1/4 of that pi around. Okay? Let's go to 135. Eight? No. Missed it by that much. Third? Yep. Nope. 3/4. And if you think about it, 45 goes into 180 4 times, and we have 3 of those. So it's 3 pi over 4. Okay? Let's go to the next one. So this would be 225 degrees. So I went pi over 4, pi over 2. So pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, and 5 pi over 4, because it's 5 45s. This one is 6 pi over 4, and this last one here, which is 315 degrees, would be what? 6 pi is right here. 7 pi over 4. Pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. and 8 pi over 4. I'm going to change colors once again. Okay? 30. Degrees is what? Pi over 6. How'd you know that? How'd you know that? Okay. Well, how do we know that 30 is pi over 6? There's 6 of those 30s in 180. So 180 divided by 30, there's 6. So that's pi over 6. Let's go to this. Well, we can go all the way around if we want, but I just want to do my 30s for now. Well, you know what? Let's do my 60. 60 would be about right here. That would be what?
That would be 2 pi over 6.
2 pi over 6 or pi over 3. 60 goes into 183 times, so it's pi over 3. Okay? Let's do my other 60s. So 60 is pi over 3. 120 would be what? 2 pi over 3. Okay? How's Mr. Doggett doing today?
Great. How are you?
I'm doing awesome. It's a Friday.
TGIF.
There you go.
We'll find Baby's dad.
Oh, all right. Good. So here I got pi over 3, 2 pi over 3. I got 180. What is 240 going to be? Come on, work your way around. Pi over 3, 2 pi over 3. 4 pi over 3. My next multiple of 60 is 300. What do I get there?
2 pi over 3.
No, 2 pi over 3 is up. It's not 6 pi over 3. It's 5. It is 5. And another way to think about it is if I take 180, or no, I'm sorry, if I take 300 divided by 60, I get 5. So that is 5 pi over 3. And then up here is just 6 pi over 3. Okay? So there's only there's actually only 3 other angles we got to put in here. Let's go back to my orange. 150. 210. What? How'd you get that so quickly? You're a stud.
No, because since the pi is 180, 30 is pi over 6.
Mm-hmm.
So it's 5, 6 for me.
Okay, there you go.
30 times 5.
Or you could say pi is 6/6. This take 1 back. This would be 5 pi over 6. So what would 210 be? 7 pi over 6. And then we've got this last one at 330 degrees. 9? Nope.
11. It'd be 10.
It would be 11. Why? Because 2 is 12 over 6. We're pulling 30 degrees back. Okay? So in my opinion, that could be generated fairly nicely. Okay? And look how pretty and colorful that is. I'm so proud. My mom would say, good job if she was still here. She's down in Texas. She's still alive, but she's just down in Texas. But she's like 86, so you never know. Okay. So that's my little deal on radians. Okay. So.
Wait, so your mom was in Texas?
Yeah. They moved down there to get out of the way, or to get out of the snow and stuff like that.
Oh.
And down there, seniors can live really cheap. I mean, they live in a senior park where you got to be 55 or older to live there. They play cards, they play shuffleboard, they swim in the pool, they play pool, they play, they had.
When did they move?
They moved there probably 20 years ago.
They're living the life.
Yeah, they're liking it. Okay. But what's also nice is my dad was in the military, and a lot of retired military, with their pensions, that's what they'll do. So he's got a lot of people with similar interests that he can visit with. Okay. So, turn it over. On the back, up top, write what a radian is. What's a radian? First thing you've got to say is it is an angle. It is the central angle formed. No. If you have more to the drawing, then possibly. You can even add a drawing to it if you want. What time are we forced to leave? 47. Okay. It's hot in here. Is it just me? Well, you got a sweatshirt on, so. Yeah. Yeah, really? I went out I put through my coat on just out of habit and got outside and I was like, whoa. Okay. So again. Yes, sir.
The central angle formed from the arc. Does that count or no?
No. Need more specifics. Yes, sir.
A radian is a central angle formed when arc length equals radians.
Equals radius.
Oh.
When the length of the arc equals the length of the radius. And you could also just add a picture. If this is R, 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 that right there is 1 radian. Now you know what a radian is. Okay? 47. Now, let's just add a couple things here. To convert. You guys know these, so I'm just going to smoke through them really quick. Okay? You are going to use the statement that pi radians is equal to 180 degrees, and then you could go ahead and multiply however you want to. Okay? So when I say, for example, if I have 60 degrees and I want to convert that to radians, I've got to multiply using dimensional analysis by this proportion, the fact that pi and 180 are the same. So in this case, if I want to convert, would I put 180 on the top or the bottom? On the bottom, so it would cancel out. So I get pi, this goes 3, so it's equal to pi over 3. Yep. So if you're going the other way, from a radian to a degree, so if I had 2 pi over 5 radians, and I want to convert 2 degrees, I'd multiply by 180 over pi, and my pi would cancel. 180 goes in, or 5 goes into 180 36 times. So that is 72 degrees. So you can go back and forth. Okay?
So will you always use 180 for those?
Oh, yeah. Because pi radians is 180. You could also use 2 pi and 360 if you wanted to, but I just think pi and 180 is a little bit simpler. Okay? Okay. We are not going to have time to get to what I wanted to get to, so I've got to improvise on the fly here, folks. Because we didn't quite get as far as I thought we might.
Are we ever going to do like the fractions of like on the unit circle?
The fractions on the unit circle? Actually, I am not. If I do have a copy of one, but you'll see how I do it, and you won't need them. Okay. So on Monday we're going to go over that, and I think you'll go, oh, I see why he says we don't need them. Okay. Okay. So there's, like I said, I was hoping we'd get through some other stuff today, but we didn't. That's okay. So here's all we're going to do. We're going to do two things. Page 238, 10 through 17, all. And I want you need to memorize something. Okay? What you need to memorize are your two special triangles. Okay? No.
Oh, we're doing these.
Yep. 1 square root of 2. 1, 2 square root of 3. Let me talk about a couple things here. I think, well, I'll let you guys finish drawing. Otherwise, you won't be paying attention to me like you pay attention to me at all anyway. Okay. So on the 45, 45, 90, I think that one's really easy. 1, 1, and if you do Pythagorean theorem, you get square root of 2. Okay, there's two equal angles. That's the one with square root of 2. This one here, if I have 1, square root of 3, and 2, just think about those numbers. 1 is 1, 2 is 2, and square root of 3 is about 1.7. So obviously 2 lies on the hypotenuse, right? Okay, and this right here, this is half of an equilateral triangle. So this whole side would be 2. So then, yeah, this is 1. 1, 2, and the longer leg is square root of 3. You got to have both those memorized by Monday. I should be able to just say, draw those, and you need to be able to draw them for me. Because, Eddie, if you know these, that takes care of all those points around your unit circle. All of them. And I'm not going to say you cannot move forward using your old way. I'm not going to say that at all. Okay?
I'll take it. Wait,
You want it?
you can give it to your favorite teacher. He said he would help with it.
Miss Gunther's not here.
Oh.
I don't blame you at all. Not at all.
I don't know.
It just is.